Hello everyone. In the previous lecture, we discussed supernode analysis. Now, we will discuss supermesh analysis. Same as like supernode analysis, supermesh analysis means for suppose in between two meshes, if there exists a ideal current source, in between two meshes, if there exists a ideal current source, then we need to apply supermesh technique. For suppose this is one mesh, and we have here another elements, and let it be I1, let it be I2, the current source is Is. So in this case, we need to apply supermesh technique. And also, if there exists a dependent current source in between two meshes, if there exists a dependent current source, here also we need to apply supermesh technique. If there is a resistance in series with current source, then also we need to apply supermesh technique. Here also we need to apply supermesh technique. And one more case is if there exists a resistance in series with dependent current source. In this case also we need to apply supermesh technique. Same as supernode technique, first open the ideal current source, then write the mesh equations for I1 and I2 combinedly. Write the mesh equations for I1 and I2 combinedly, then apply KCL. Then solve the linear equations, we will get unknown elements. Okay, here actually the mesh analysis means KVL plus Ohm's law. Supermesh analysis means in addition to KVL and Ohm's law, we get here KCL. We will get KCL. So the supermesh analysis means KVL plus Ohm's law plus KCL. Now let us solve some problems on this supermesh technique. First question is find the power dissipated across the 4 ohm resistor. This is the given circuit. First assume mesh currents or loop currents. This is I1, let it be loop A, and this is I2, let it be loop B, and this is I3, let it be loop C. Okay, we take all these three currents are in clockwise direction. You can take any direction. Now, if you observe here, in between these two meshes, there exists a independent current source. In between these two meshes, there exists a independent current source. So we need to apply supermesh technique. So first, in supermesh technique, what we are doing? First, open the current source. Open the current source means just forget about this one. Then write the equation for I1 and I3 combinedly. Write mesh equations for I1 and I3 because it is a supermesh technique. Because this is a supermesh technique. Now, so for this loop, so what are the sources here? Forget about current source, only consider voltage source. So here it is 8 volt source. The current is leaving the positive terminal of 8 volt source. So 8 plus 8 plus 8. All sources are completed is equal to, what is the passive element? Coming to this loop, is there any voltage source here? There is no voltage sources, so this is 0. Now sources are completed. What are the passive element for this loop? This is one passive element and this is another passive element. You can exclude this passive element or you can write the passive element in the equation, but this, if you write the current equation or voltage equation for this 2 ohms, that will cancel. Okay, I will show you. For this 6 ohms, 6 into, so this current is coming like this and this current is coming upwards. This is downwards, this is upwards. Both are in opposite direction. So here it is I1 minus I2. Now coming to this 2 ohms plus 2 into, this is downwards and this current is upwards. I1 minus I3. For this loop, this is completed. So this is swapper mesh. So write the equation combinedly. Now plus, coming to this loop, there is no sources here. So for 2 ohm resistor, 2 into I3 minus I1 plus for this 4 ohm. For this 4 ohm, this is left to right. I3 is left to right and I2 is right to left. So both are in opposite direction. So plus 4 into I3 minus I2 plus here there is a 9 ohms. So current is coming downwards. So only 9 I3. Okay. By solve this, if you observe here, this is I1 minus I3 and this is I3 minus I1. So both are cancelled. So that's why you can exclude this 2 ohm resistor or you can include this 2 ohm, but this will cancel. Now this is 6 I1 minus 10 I2 and next one is this one plus 13 I3 is equal to 0. Let it be equation 1. Now apply KCL here. Apply KCL at this node. Okay, this loop current indicates this branch current, so it is I1. Here also this loop current indicates this branch current, it is I3. If you apply KCL here, what you are getting? The incoming currents are 5 plus I3. So incoming currents are 5 plus I3. What is outgoing current? I1. This is leaving the node and this current are entering to the node. So 5 plus I3 is equal to I1. From this, I1 minus I3 is equal to 5. Equation 2. Or without KCL, we can directly write the equation for. So if you observe here, I1 is same as 5 amps. This is I1. This I3 is opposite to the 5 amps. So I1 minus I3. Here this is same as 5 amps and this is opposite to the 5 amps. So I1 minus I3 equal to 5. I1 minus I3 is equal to 5 without applying the KCL. Now write the mesh equation for loop B. Write mesh equation for loop B. What you are getting? Here there is no sources associated with this loop. So sources are 0. So 0 is equal to, for this passive element, this current is upwards and this current is downwards. Both are in opposite direction. So we are considering this loop, that is we are writing this loop. So 6 into I2 minus I1. Coming to this element, this I2 current is right to left. This I3 current is left to right. So both are in opposite direction. Plus 4 into, first write I2 because we are considering loop B. So the loop B current is I2. So first I2 minus I3 plus here one passive element, that is 1 ohm. So 1 into I2. So you will get minus 6 I1 plus 11 I2 minus 4 I3 is equal to 0. Let it be equation 3. Solve 1, 2, 3. You will get I1 is equal to 5.5321 amps. I2 is equal to 3.211 amps. And I3 is equal to 0.5321 amps. Okay. Now find the current to this 4 ohm resistance. So which one is larger current? Here I2 is larger current and this is small current. So take the current direction like this, that is right to left. So what is I4 ohm? Let it be I4 ohm. Now the current flowing through the I4 ohm is equal to I2 minus I3. So I4 ohm is equal to 2.6789 amperes. So what is the power dissipated by the 4 ohm resistor? V4 ohm is equal to power dissipated by the resistor is I square R. So it is I 4 ohm 2.6789 whole square into 4. So what is P4 ohm? P4 ohm you will get 28.706 watts. For the same circuit, we can solve by using nodal analysis. Okay, here this node voltage is 8 volts. This node voltage is 8 volts. It is short circuited. So this node voltage is same because it is short circuited. With respect to this node voltage is 8 volts. Let it be V1 and let it be V2. Write the node equation for V1. Okay, if you observe here V1, we have 3 branches. Whenever you want to write the node equation at any node, that node has, we assume that node has highest potential. If this node has highest potential, all current must be leave this node. All currents must be leave this node. So the current leaving this node is V1 minus 8 by 6. And here the current leaving this node is V1 minus V2 by 4. And here this branch current indicates this current. So this source current indicates this branch current. So here it is plus 5 is equal to 0. 2V1 minus 16 plus 3V1 minus 3V2 plus 60 is equal to 0. 5V1 minus 3V2 is equal to minus 44. Equation 1. Now write the node equation for V2. Here this is highest potential. We are assuming this is highest potential. All current must be leaves this node. So for this V2 minus 8 by 1. For this branch current is V2 minus 8 by 1 plus this branch current is V2 minus V1 by 4 and this branch current is V2 by 9 is equal to 0. This is 36 V2 minus 288 plus 9 V2 minus 9 V1 plus 4 V2 is equal to 0. Minus 9 V1 plus 49 V2 is equal to 288. Let it be equation 2. Solve 1 and 2. We get V1 is equal to minus 5.9266 volts. V1 is equal to minus 5.9266 volts and V2 is equal to 4.7889 volts. Okay, now the power dissipated by this 4 ohm is P is equal to V square by R. Okay, power dissipated by resistance is V square by R. So V means voltage across this 4 ohm is V1 minus V2. The voltage across 4 ohm resistor is V1 minus V2. So here it is V1 minus V2 whole square by 4. So if you solve that, substitute these values in this equation and solve this, you will get power is equal to 28.706 watts. Okay, in both cases we got same answer. So choose the which technique is you feel comfortable. In the next video we will discuss some more problems on this concept. Thank you for watching.